Chatbots have become increasingly popular recently thanks to what we would call large language models, or LLMs. These LLMs can be thought of as the brain behind things like ChatGPT, Anthropic Claude, Google's LaMDA, and pretty much any other modern chatbot system. Now, this brain, the LLM, works by training on a huge amount of text data, usually scraped from the internet, and trained over many years of GPU training hours. Over this long and expensive training period, the LLMs are able to begin to identify patterns in language and actually memorize information that was seen during the training process. But there are still a lot of challenges with this that LLMs really struggle with. LLMs really struggle with queries that require knowledge of internal or domain-specific information or up-to-date information, because none of those things have been included within the training dataset. And if it hasn't been included within the training dataset, there's actually no way of getting an accurate answer from an LLM on that topic. So some common issues that we usually see include hallucinations. So this is a very common problem when an LLM will just guess, but they will do so very convincingly. And these hallucinations are very unlikely to be noticed by users. We also have limits in the amount of text that can be fed to a large language model. So within the prompt, what you can do is add additional information in there that can help the LLM answer a question. But we cannot feed in too much data. There are currently limits. At the moment, the top limit for GPT-4 is 32,000 tokens, which we can think of as being word or subword chunks of text. Now that's a lot, but it's not actually that much if you're asking a open-ended question. We also have the issue of slow response times. As soon as we start adding more text into a LLM prompt, it is going to take longer for that LLM to process through everything and generate an answer. And there's also the problem of knowledge updates. If you have a database that is regularly updated, a LLM isn't going to be able to keep up with that. In order to train an LLM on new information, you're going to need thousands of GPU training hours. That's both slow and expensive. You can think of this as the language model is actually stuck in a frozen version of the world that it saw during training, which isn't easy to change. Now, there is a way around this, and that is where vector databases like Pinecone come in. So a vector database, you can think of it as a managed way of controlling the information that is being presented to a large language model. So unlike the internal memory of a large language model, a vector database allows you to add new records, delete records, update records, as you would with a normal database, which means we can actually keep information up to date. We can refer to internal documents, and we can do that all very easily. With that, the large language model now has a window into the external world through our vector database. So thanks to this, we can get much better results. With Pinecone, we can scale this to billions of records whilst limiting the number of relevant contexts we return to our large language model. So we're keeping context limits in check whilst actually searching across a huge knowledge base. We also have very low query latencies, so we can find these results in a matter of milliseconds. So we're not adding noticeable latency to the user experience. So adding this external knowledge base to chatbots has a huge potential in reducing hallucinations, improving the trustworthiness of chatbots, and simply improving their performance. They can now answer questions much more accurately and about much more information, such as internal company documents or the latest world events. So that's our summary on how external knowledge bases like Pinecone work with chatbots. We hope this has been interesting and insightful. So thank you very much for watching the video, and we'll see you again in the next one.